Okay, so we're going to be solving practice problem 3.2 of the book of Fundamentals of Electric Circuit by Charles Alexander. In this question, we have been asked to find out the node voltages V1, V2 and V3 using the technique of nodal analysis. So the very first thing that we are going to do is determine the direction of current flowing in the circuit. So the current flows here, it goes here, and it goes here. The current flows here, it goes here, and the current goes here. Okay, this is the very first step. We have determined the direction of current flowing in the wires in the circuit. Okay, so now we're going to be applying Kirchhoff's current law on each respective node, which is Kirchhoff's current law, Kirchhoff's first law. It states that current entering a junction is equals to current leaving the junction. So this is the junction 1, junction 2, junction 3, or we can say these are nodes as well. Okay, so the current entering, let us write KCL at node V1. The current entering node V1 is 4 amperes, and the current leaving node V1 is V1 minus V3 by 2 plus V1 minus V2 by 3. Alright, so this would be 6. Okay, let us simplify this equation. 2 3 is 6, so this would be 3V1 minus 3V3 plus 2V1 minus 2V2. Hope that's clear. Okay, simplifying further, this would be 24, and 3 plus 2 would be 5V1 minus 2V2 minus 3V3. So the final result of this equation is 5V1 minus 2V2 minus 3V3 is equals to 24. This is the equation number 1 that has been formed. Alright, now the second step is to apply KCL at node V2. KCL at node V2. Okay, the current entering node V2 is this current, and the current leaving is this current. Alright, so the current entering node V2 would be V1 minus V2 by 3 and 4Ix, and then the current leaving would be V2 by 4. Now, as we can see that since we have 3 node voltages V1, V2 and V3, so we're going to be ending up with 3 equations. And similarly, since we have 3 equations, we should have 3 variables to solve and to find the numerical values for. But in this equation that we just formed, we can already see that there are 4 variables, V1, V2, and there is Ix as well. And in this equation, if we see, in equation number 1, we have V1, V2, V3, right? So we cannot have involvement of another variable, which is Ix. So we should write Ix in terms of voltage as well. So as we can see in the circuit that they have made it very clear that the current flowing in this wire right here from the node 2 to the ground is the current Ix. So we should write the expression for current Ix. The expression for current Ix would be Ix is equals to V2 by 4. This is the current Ix. Alright, so let us now substitute the value of Ix in terms of V by rewriting this equation. V1 minus V2 upon 3 plus 4 V2 by 4 is equals to V2 by 4. 4 cancels out. This would be V1 minus V2 by 3 plus V2 is equals to V2 by 4. Alright. Now let us simplify this equation. this would become V1 minus V2 plus 3V2 multiplied with 4 is equals to 3V2. So 4V1 minus 4V2 plus 12V2 is equals to 3V2. Alright, now simplifying further, it would get us 4V1. Right, 4V1 minus 4 plus 12 minus 3 would give us 5V2, 0. This is equation number 2. Oops. Equation number 2. Alright, let us now find the equation for node V3. We have to apply KCL at node V3. Alright, so the current entering node V3 is this current, and the current leaving is this, and the current leaving is this as well. Okay, so let us write down. Let me just separate this. Okay, KCL at node V3. The current entering is V1 minus V3 by 2. The current leaving is V3 by 6 and 4Ix. I'm just directly gonna substitute Ix in terms of V. Alright, now let us simplify this. This would be V1 minus V3 by 2, and this cancels out. This would be 6 and V3 plus 6 V2. 2 ones are 2, 2 3s are 6. So now this would become 3V1 minus 3V3 is equals to V3 plus 6V2. And let me just bring it right here. Okay, simplifying this further would give us 3V1 minus 6V2 minus 4V3 is equals to 0. This is the final result for the equation formed at node V3. Okay, since we have formed the three equations for the three nodes, we can just simultaneously solve these equations. I'm going to use the calculator to plug in the equations and directly get the answers for it. 5 minus 2 minus 3, 24. 4, 5, 0 and 0. 3 minus 6 minus 4 and 0. So we have got the answers. V1 is 32 volts. V2 is minus 25.6 volts. V3 is 62.4 volts. I hope this question was clear to you guys, and I will meet you guys in the next video. Thank you for watching.